This is section 2.1, functions. So a function is a relation that associates each element of the domain, which is your x, to exactly one element of the range, which of course is going to be your y. So part of this, again, should be a little bit of a review. You've had this in Math 2 and Math 3. So for example 1, if we have f of x equals 2x squared plus 5x, if we find f of 3, well, 3 is in the place of x. So what we're going to do here is anywhere you see an x, you're going to plug in the 3, and you will simplify, okay? So if you are typing this in your calculator, just be careful with order of operations, because sometimes the calculator's order of operations is a little bit different. Just depend on how you type it in, parentheses and stuff like that, or Desmos. So just, be cautious of that. And so 2 times 3 squared plus 5 times 3 is going to give us 33. All right, for B, we're going to plug in negative x. So f of negative x, we have 2 times negative x squared plus 5 times negative x. So remember, we've already talked about if we take negative x and you square it, a negative becomes positive, because negative x times negative x is going to be positive, and of course it's still going to remain squared. And then we have minus 5x. We'll just move that negative out in front of the 5. Okay, so on this one, notice the negative is out front. So what we do here is I'm just going to put a negative, and I'm going to put everything in parentheses. And then what I'm going to do is we will just distribute the negative. So we'll get negative 2x squared minus 5x. And we can't simplify that any further. All right, for example D, everywhere you see an x, we're going to plug in x plus 5. So we have 2x plus 5 squared plus 5 times x plus 5. Okay, so again, don't forget order of operations. So you want to do this first because of the power, because it's squared. Remember, power's first. All right, so I've still got my 2. Now, I'm going to use the shortcut that I've talked about before. Remember, the saying, some stars don't always shine. All right, so if we have x, we're going to, that first s stands for square the first. So x squared. The second s is same sign. The d stands for double the product. So you're going to take the product, okay, so which is just 5x, and then you double that, so you get 10x. And then the a is always plus, and the last s is square the last. All right, now we're going to distribute the 5, so we have 5x plus 25. All right, so now we will distribute our 2. So we'll have 2x squared plus 20x plus 50 plus 5x plus 25. All right, and now we just need to combine like terms. So we have the 2x squared, so that's the only one with an x squared. I've got 20x and 5x that I will add together, so give me 25x. And then I have the 50 and the 25 to give me 75. All right, for E, I'm going to plug in a negative 2x. So negative 2x squared plus 5 times, negative 2x. Okay, so again, make sure you square this first. Don't multiply by the 2 and then square it. You got to follow order of operations. So if we square that, negative 2 squared is going to be positive 4, and then the x, of course, turns into a square. And then, let's see, I guess I should have put a minus here. 5 times negative 2x is going to give us negative 10x. And then 2 times 4 gives us 8, so we have 8x squared minus 10x. All right, so on F, we're going to plug in x plus h. So we have 2 times x plus h squared plus 5 times x plus h. Okay, so again, I'm going to use my shortcut. Some stars don't always shine. Keeping the 2 out front because I have to square that first. So square the first, which would be x squared. Same sign, so I have a plus in there, so I'm going to do a plus. Double the product. Well, if I multiply the x and the h, I get xh. So if I double it, it's 2xh. And then always plus and square the last. Okay, and then I can distribute my 5. So 5x plus 5h. And now I'm going to distribute my 2. So I'll have 2 times x squared, which is 2x squared, plus 4xh, plus 2h squared, plus 5x, plus 5h. And I want to check to see if I have any like terms, which I don't. So this whole thing is my final answer. Okay. All right, so on G, you will recognize this a little bit later on, but for now, we're just plugging in. Now, we just did the f of x plus h. We've already solved that. So I'm going to go ahead and plug that in on the top. I have the 2x squared plus 4xh plus 2h squared plus 5x plus 5h. And then minus f of x. So I'm going to subtract 2x squared plus 5x, and then all of that is over h. Okay, so if I distribute my negative, 2x squared, let me just rewrite this again. So minus 2x squared minus 5x all over h. So on top, what I want to do is I want to combine like terms. Well, notice I have 2x squared minus 2x squared. So those are going to cancel. I also have a 5x minus a 5x. So those are going to cancel. And that looks to be all that's the same on top. So now I have 4xh plus 2h squared plus 5h. It's looking a little bit better with an h on the bottom. Okay, so I can simplify, being that all of these terms have an h, I can reduce them all by h. Okay, so that's going to give me 4x, because this h will cancel. H squared over h, the squared cancels. So I have 2h. And then 5h over h, that h will cancel with the h on the bottom. So I'm left with 5. So then this is my final answer. Okay, example 2. Stating the domain of each function in interval notation. So remember, domain is just, you're looking at it from left to right. How far left does it go? How far right does it go? And we're looking at the x values. Okay, so on A, we have 3x minus 7. Well, think about what the graph 3x minus 7 looks like. 3x minus 7 is just a line. It's going forever to the left, and it's going forever to the right. So our domain, and we do a capital D, is negative infinity to positive infinity, because it goes forever in both directions. Okay, on B. Now, the situation that we have in B is we have a fraction. Remember, in fractions, we can't divide by 0. We can't have a 0 on the bottom. So we're going to have places where that cause us issues for our domain. So what we're going to do is we are going to take our denominator, and to figure out, what it can't be, we're going to set it equal to 0 to figure out what our numbers are of what's going to give us problems, what will give us 0 on the bottom. So I'm going to factor this. So two numbers that multiply to be 2 and add to be negative 3 are negative 2 and negative 1. And remember, when we set each equal to 0, we'll get x equals 2 x equals 1. And so now I want to put this in interval notation. So, domain. So these are the two places that, is going to give us issues, but we go from negative infinity to 1, and we go in numerical order, and then 1 to 2, and then 2 to infinity. So when you're doing this, you always start at negative infinity, and then you go in order with your numbers. You make like a set of parentheses for each set of numbers, and then with your biggest number, it's that number to infinity. All right, so for C, now on C, we have a fraction, so it can't equal 0, or I guess I could have put it can't equal 0. And you have a square root. Remember, square roots can't be negative. So we have two things going on here. So to figure out, what it can't be on this one, we're going to take the x plus 2 and say that it has to be greater than or equal to 0, or sorry, just greater than 0, okay? It's got to be greater than 0 because it's got to be positive, and it can't equal 0. So I'll get x is greater than negative 2, and if I put that in interval notation, so x is greater than, remember greater than is going to infinity. Think of all the numbers that are greater than 2. So negative 2, and it gets a parentheses, to infinity. All right, for, where are we here? Okay, so for D, again, this one just can't, this one's similar to B. We can't have 0 on the bottom. So we take the x cubed minus 4x. We're going to set it equal to 0 and solve. So I factor out an x, which leaves me with x squared minus 4. And I see that this is a difference of squares. So x plus 2, x minus 2 equals 0. So I have x equals 0, x plus 2 equals 0, and x minus 2 equals 0. So I'll get x equals negative 2, and x equals a positive 2, okay? So I may just make myself a little note here, negative 2, 0, 2, just put them in numerical order to help me when I write my domain. So I start with negative infinity to negative 2, negative 2 to 0, 0 to 2, and then 2 to infinity. And that is my domain. And notice I'm using parentheses. Okay. To determine if an equation is a function, then what that means is that we can only get one answer for y, okay? So when you plug in an x, you can only get one answer for y, okay? So for A, if I plug in negative 1 for x, so negative 1 cubed gives me negative 1, only gives me one answer. If I plug in 2, 2 cubed is 8, only gives me one answer. So this one is a function. Okay, so for B, again, if I just start, think about plugging in numbers. If I plug in negative 1, I'm only going to get a positive 1. I plug in one answer, I'll only get one answer. I plug in 1, I get positive 1. I still only get one answer. Even though they're the same, that's okay, but I'm only getting one answer every time I input something. So again, this is a function. Now, on C, all right, so on C, so we have a y squared. Now, y is not by itself. One thing we can do here is we can plug in a 0 for x. So if I plug in 0 for x, then that just gives me y squared equals 1. Well, if I'm solving for a square, if I want to reduce the square, I take the square root of it, or get rid of it, cancel out a square, I take the square root of it. And so remember, when we take the square root, that gives me a plus or minus. Well, this is two answers. Y can be 1 or y can be negative 1. So y can be two different answers if I plugged in one number, if I plug in a 0. So if I plug in a 0, and you can pick any number, 0 is usually the easiest because it just gets rid of it. But I got two answers. So this one is not a function. All right, for D, Well, I've got y equals y is by itself, but notice you've got the plus or minus here. That's already telling you you've got two answers. You've got a positive version and you've got a negative version. So this one is not a function. And then on E, if I think about just plugging in numbers, you know, if I plug in a 1, 3 times 1 is 3 minus 1, I get 2, and I'll get 2 over 3, so 2/3, I just get one answer. So even though it's a fraction, like we could get undefined on the bottom, that's okay. But if I plug in numbers, I'm still only going to get one answer. So this one is a function. Okay, so for example 4, we're given f of x is 1 over x minus 2 and g of x is x over x plus 5. So we're going to do the operation it tells us to do, and then we're also going to find the domain for parts A through D. So the first thing I'm going to do up here is I know that like x can't be 2 because that would give me a 0 in the bottom, and I know x can't be -5 because again, -5 plus 5 gives me 0. I can't have a 0 on the bottom. So I'm going to go ahead and make that note because that's going to help me with my domain no matter what I get when I simplify my problems. I can't, even from the beginning, I can't have a 0 in my fractions. So f plus g of x means that I'm just going to add. So my f of x is 1 over x minus 2 plus, and my g of x is, make that an x over x plus 5. And so it doesn't say anything about simplifying. So that's my answer. So I don't have to simplify it. And then when I do my domain, I know that it can't be -5 and 2. So negative infinity to -5, union -5 to 2, union 2 to infinity. Okay, subtraction, f minus g of x. So again, 1 over x minus 2 minus x over x plus 5. Okay, so there's my answer. Okay, nothing really changed there, so my domain is still going to be like it was on A, negative infinity to -5, union -5 to 2, union 2 to infinity. So there's my domain. Now, on C, I'm going to multiply the 2, 1 over x minus 2 times x over x plus 5. So there's my answer. Again, my domain is going to be the same because the bottoms, like I still can't have 2 and I still can't have -5. So negative infinity to -5, -5 to 2, 2 to infinity. Okay, so on D, we're going to divide. So my f of x, I've got 1 over x minus 2 over x plus 5. Now, this one I can't leave because this is called a complex fraction, okay? And since it is a complex fraction, you must simplify, okay? So even though it doesn't say anything about simplifying, if it is a complex fraction, you have to simplify it, okay? So when I bring this down, remember, when you have division of fractions, bring the first one down, change the sign to times, flip the second one upside down. So I'm going to get x plus 5 on top, and then I'm just going to put the x out front, x times x minus 2 on the bottom. Or if I want to take that a step further, x squared minus 2x. Okay, so there's my final answer. Now, here I do have to worry about, being that I did get a new fraction for my answer, I do need to factor this, okay? So, we've already factored it here. So I know x can't be 0, or we'll do for 0 for our domain. And then, of course, we still get 2 again, which we've already used. But now we're going to throw in 0 into our main. It still can't be the original 2, and negative 5. So for my domain, okay, so remember we've got, if I put these in order, negative 5, 0, and 2. Sometimes I just like to put my numbers in order on number lines so I can see how I'm going to write it out. So negative infinity to negative 5, negative 5 to 0, 0 to 2, and 2 to infinity. Okay, so now for E. So we have already done all these. Like, we've already done F plus G, and then it says a 4. So we can just refer back to A, and now we're just going to plug in 4 everywhere we see X. Okay, so I have 1 over 4 minus 2 plus 4 over 4 plus 5. So we'll get 1/2 plus 4 ninths, and 1/2 plus 4 ninths will give me 17 over 18. And then always give reduced fractions. Reduced fractions are best. And we don't have to do the domain on these. Okay, so now we're doing the F minus G. So again, I'm just going to plug in 3, and I can just refer back to B. So I have 1 over 3 minus 2 minus 3 over 3 plus 5. So I get 1 over 1, which I know is going to turn into a 1, minus 3 over 8. So basically I have 1 minus 3/8, which will give me 5/8. All right, on G, this is where I was multiplying them, but now I'm going to plug in a 1. So I'm going to look back up at C. So I have 1 over 1 minus 2, and then 1 over, because I'm plugging in 1 for X, 1 plus 5. So I have 1 over negative 1 times 1 over 6. So that's going to give me negative 1/6. All right, on H, I'm plugging in a negative 1 to where when I divided them. So I just refer back to D, where I have x plus 5 over x squared minus 2x. So I have negative 1 plus 5, negative 1 squared minus 2 times negative 1. So this will give me 4, and then 1 squared is 1, and that's going to be plus 2, so 4 over 3 to give me 4/3. And that concludes this section of notes.